Welcome to today's lesson. Before this lesson you should have studied the atom, ionizing radiation, and the dangers of ionizing radiation. So let's start by stating what is shown in this diagram on the right. Then describe what it is made of, that is its composition, and then what is its relative mass and what is its relative charge. Pause the video if you need time to think about this. I'll give you the answer in a moment. So what we can see in this image is an alpha particle. It is made of 2 protons and 2 neutrons. This means that its relative mass is 4 and its relative charge is +2 due to the 2 protons. So today's lesson is called alpha particles. Can you name 3 types of ionizing radiation? State what happens to like charges and opposite charges when they are near each other. State what is meant by penetration, and compare the relative ionizing potential of all 3 ionizing radiations. Check through your notes to remind yourself of the answers to these questions. If you can't answer these questions yet, you need to go back over the previous lessons. So let's start by looking at unstable isotopes. There are many ways that isotopes can be unstable. They can have too many neutrons, too few neutrons, or be too large. If an isotope is too large, it will emit an alpha particle, and this will reduce its atomic mass by 4. It will also reduce its atomic number by 2. In your notes, you should sketch a simple version of figure A to show the emission of an alpha particle from the nucleus. Then explain why an isotope may emit an alpha particle. Now, alpha decay happens when we have a heavy, unstable nucleus, and it emits an alpha particle to become lighter and more stable. An alpha particle is emitted rather than some other number of protons or neutrons because the helium nucleus, which is 2 protons and 2 neutrons, is extremely stable. And so, if nucleons have enough energy to escape the nucleus, they do it as a pair of protons and neutrons. So an alpha particle escapes. It is the same as a helium nucleus, and this pairing of 2 protons and 2 neutrons is extremely stable. Explain why alpha sources do not emit other numbers of protons and neutrons. Now let's look at the properties of an alpha particle. Before scientists knew what was inside an alpha particle, they were able to determine its properties. Placing an alpha emitter, such as polonium perhaps, between 2 charged plates, one positive and one negative, alpha particles would curve away from the positive and towards the negative. Since we know that like charges repel and unlike charges attract, it meant alpha particles must be positively charged. The more curved the path, the larger the charge, and also the smaller the mass. So the curvature of this particle will tell us the mass and the charge of that particle. Explain why an alpha particle will accelerate towards a negative electrode. Then, state what determines the path of an alpha particle traveling between two charged metal plates. Now let's look at penetration depth of an alpha particle. Figure C shows that alpha particles can only penetrate about 15 centimeters through the air. And figure C also shows that alpha particles cannot penetrate through paper or any material thicker or denser than paper, such as rock or metal or even human skin. This is because alpha particles are large, so they are likely to collide with atoms in the paper or air. They carry a strong +2 charge, so they quickly gain electrons from other atoms, and they are slow moving, so by the time they collide with an atom, they haven't travelled very far. Now, when I describe them as slow moving, keep in mind this is slow moving compared to the other two forms of ionizing radiation. They do actually travel extremely fast compared to the molecules in the air, but just slower than beta and significantly slower than gamma. Sketch a diagram of these figures. State what the penetration depth of alpha particles is, and explain why alpha particles do not penetrate far through air. Finally, let's look at a smoke detector. So figure E shows an alpha source emitting alpha particles, which ionizes atoms in the air. The charged ions can now carry electrical current between the electrodes. However, if smoke gets between the cathode and anode, it absorbs the alpha particles, stopping the air from being ionized, and therefore stopping the current from flowing. This sets off an alarm. So in the diagram you can see the alpha source. That alpha source is producing alpha particles which ionize the air, making some molecules in the air positive. This will cause them to move towards the negative plate, and so we have an electric current. State what a smoke detector is. Explain what happens when alpha particles are emitted between the metal plates, and explain how smoke stops the current flowing between the two plates. Now let's do some problem solving regarding alpha particles. State what happens to the atomic number and mass number of a nucleus when it emits an alpha particle. Use a periodic table to identify what element will be produced when the following nuclei emit an alpha particle. We have uranium-238, tellurium-129, neodymium-144, and americium-243. For the isotopes in question 2, state their mass number and their atomic number after the alpha decay. If you'd like to read the textbook page, you can see it on the screen now, and you'll see all the questions we've just gone through on the bottom right.